Okay, so the next hydroxyl we are going to take a look at is the cyclic alcohol structure. Okay, so here the only difference is because we are dealing with a cyclic structure, it is critical that we include cyclo, then the parent, and then again drop the E and add OL. All right, so let's take a look at our first example. So our first example here, we have a 5-membered ring. So we have a cyclopentane, but again, this is an alcohol. So the name for this is going to be our cyclo, because it's a ring, pent, and again, I'm going to drop that E and add OL. Now, since that is the only group on the ring, I do not have to identify this as being on carbon number 1. It is understood to be on carbon number 1. All right, so in our second example here, we have our alcohol group and we have 2 substituents on our 5-membered ring. So again, we're dealing with a pentanol. So let me go ahead and write that down. Well, we have a cyclo, pentanol. And now it's going to be important for me to number and give my substituents a locant value. Remember that the alcohol is always on carbon number 1. That one is going to take priority. So if I count this way, alcohol is on carbon number 1, my methyl group is on carbon 2, and my ethyl group is on carbon 4. If I number in the other direction, my alcohol is still 1, my ethyl group would be number 3, and my methyl group would be number 5. I want to use the purple numbering system. That's going to give me the lowest combination of locant values. So now I can go ahead and add my substituents. Remember that you need to put these in alphabetical order. So E comes before M, so this is going to be, let's see if I can get this set up right. For ethyl, I just got done saying E comes before M, and 2 methyl. Whew, there's an L there. Methyl, that's a Y, cyclopentanol. So 2 for ethyl, 2 methyl, cyclopentanol.